We'll now give some definitions for the coordinate vector. If B is a basis for vector space V and X is an element of B, then the coordinates of X relative to using basis B is called the B coordinates of X, and the weights associated with this B coordinate C1 to Cn are related to X, the original vector, by the linear combinations using C1 as a scalar multiplying the column vectors in basis B in this form, an ordered form, where B1 to Bn is multiplied with C1 to Cn. So this is the linear combination. And again, the representation is X, the original vector, is B1, B2 to Bn, linearly combining with C1, C2 to Cn, or in the previous slide we show it as PB, representing the B basis multiplying C vector. In fact, when this C vector, we now call this, the C vector, as the X vector in the B coordinate. So we call this the coordinate vectors of X relative to B, or we say it as the B coordinate vector of X. So to repeat, X of B is nothing but this vector of C1 to Cn. Let's have an example. Now, we have a vector space R2. We're given B1 to B2 as the basis. B1 is 1, 0, B2 is 1, 2. So we can put it as this way. This is PB. This is B1. This is B2. The two columns are independent, and these two columns spans R2. So PB is a basis. We are given that the coordinates vector X using the B basis is -2 and 3. So what it means is that this is X using the coordinate, using the basis B. This is -2 and 3. And we are asked to find X. So the formula to find X is nothing but multiplying X of B with the basis, and we would get X. So this is how we calculate this, and X therefore is nothing but -2 times 1, 0. This is B1 plus 3 multiplied by 1, 2. This is B2, and the weights are, this is C1, which is here, and C2, which is here, equals to, answer is 1, 6. So what is 1, 6? 1, 6 is X, and X is a vector belonging to R2. Then you will be thinking 1, 6 must be with respect to something, right? Because these are coordinate vectors. 1, 6 is with respect to something called the standard basis, because the standard basis E1 and E2, this is E1, this is E2, and let's describe the standard basis. Is nothing but a vector that has 1 in only one of the element. E1 means the first element is 1. E2 means the second element is 1. the rest is 0. So this is the orthogonal basis or the standard basis, meaning that we have x, y, and z, and kind of representation. They are orthogonal to each other. They are the simplest basis that we typically deal with, and therefore 1/6 is with respect to the standard basis, because you can think of this as 1/6 is the first element 1 multiplied by E1, the second element multiplied by E2, and we will get 1/6.